Hello, everyone. Thanks for joining me today. I'll be working on drakon render again. Let's switch to the code view. So on the agenda today is a natural follow-up from what I worked on yesterday, and that was the choice icons, if I'm not mistaken. Choice icons, yes. Today I'll be working on case icons. So choice I implemented yesterday. Today we're going to see if we can implement these case icons. And there's also one thing that I would like to try. Again, I found it while reading this Effective Haskell. Great book. I would really recommend it. I learned a lot about the point freestyle, which I don't normally use. And I'm still on the fence whether I should or not. I think the code that I'm producing during these sessions is pretty readable and pretty maintainable, especially for our human listeners and maintainers. But the point freestyle is also very tempting, and the author seems to be a fan of it. Nevertheless, I'll just take a note to try and to show you what I mean later during the session when the icon is implemented. Perfect. I have a note here. I won't forget. There's also one more thing that I would like to mention, and it is the fact that at this stage, you probably expect that I will never be happy with any sort of more complex piece of code. And in this code base, the layout engine is the most complex piece of code. So while I have managed to implement the path balancing so that the paths and connections don't clash, I'm not really sure if this is the best approach. And looking at the drakon documentation or the drakon white paper, I'm sort of getting a feeling that I may have approached the drakon diagram syntax slightly incorrectly. What I mean by that is, if you look at the diagram inputs, what we have is just a straight up list of icons that are deserialized. So this is like a one-dimensional structure. Okay. Well, in fact, if you read through the documentation and the white paper, you will find out that Drakon is more like a set of drakon letters and words nested inside each other. So it's more like a recursive data type that would be more suitable to represent a textual representation of a diagram, if that makes sense. So instead of having like a 1D data structure that represents the diagram, I fear we might have to resort to changing that slightly and having the diagram implemented as a recursive data type, where if an icon has a child, that child is not simply beside it in the JSON or whatever file that represents the diagram, but instead that child is inside the icon who is the parent. That idea started a couple of days ago in my head, and I will most likely action it at some stage in the future. But first, what I'm always worried about is the cornerstone of what got me into drakon in the first place. How do you prevent icons and connections from clashing, and how do you retain that clear, crisp representation of very complex designed flows, or how do you call it, flowcharts, or workflows, however you want to call this. So if we can retain that degree of clarity, representing drakon icons differently, I'll be tempted to experiment with that. However, the idea is still brewing in my head. It's still maturing. For now, implementing additional icons and shapes is not contradicting what I've just said. Those icons are still very usable and will be, even if I decide to change how we represent the diagram structure. So why don't we let the idea brew for a little bit longer, mature for a bit longer, and in the meantime, I can just focus on implementing stuff that is predictable and not that complex. Famous last words. I'm slightly worried today that I won't be able to, if this renders, I won't be able to represent that little line in the shape, but I'll be very happy to be proven wrong. All right, enough of me rambling. I hope you have a drink of your choice ready. I have my coffee here, and let's get coding. These are case icons, right? Yes. I'm not sure if you've noticed, but I've started experimenting with Ghosty, this new terminal emulator. Well, new at the time of recording this video. And it's pretty good. I would recommend it. I've been using a combination of iTerm 2 and just plain terminals that come pre-installed with any operating system I've been using. iTerm 2 has been my favorite for a number of years now. And Ghosty is pretty good. I like the configuration and I like the speed. What I'm missing is the ability to name tabs. So I usually have many different containers open for various projects, and it is useful to name a tab, give it a color, give it a description. Ghosty is missing that, but I noticed there is an issue open already in the Ghosty's repository, or a discussion there is open, so it looks like the maintainers are working on it. I'll probably be using Ghosty with iTerm 2 going forward. These are both great terminal emulators. Okay, so just like yesterday, let's start with data types. I love this. For those of you who remember how long the project used to take to build and the environment and how long the environment took to start. Yeah, I do appreciate the speed with which the environment starts now and the project builds, and it's thanks to those Cabal volumes. So now we have the expected warnings in the renderer. In line 230. Oh, sorry, it's here. So just to stay safe, let's reuse the choice shape. And in primitive diagram 6, I believe, let's change the action. Oh, sorry. Let's go back to drakon. Render. What would be the most sensible place to put that icon in? So, choice is really very similar to a question, but it can have multiple children. Well, the way it works, not the way it looks. So, just for the sake of the argument, let's change this icon, lift weight, lifted the weight from action to case. It's not an idiomatic / correct drakon diagram, but it's not supposed to be it. We're just implementing an icon. And now run. We need diagram 6 though. I'll probably create a separate issue. Perfect. Lift the weight as here. Great. And I'll probably create a separate issue to replicate the sort of diagram that Stepan Mitkin created in his like a demo or introduction to primitive diagrams. And just not to leave this empty, I'm going to update it to test. So now let's go to the renderer, and instead of having a choice shape, let's implement a case shape. So remembering my mistakes from yesterday, I need to remember that these vertices are really offsets. They're not global positions. So for now, let's just reuse this shape. Let's call it. Okay. Case shape. All right. So we start from 0, 0, which in our case, what could be a good place to start? I think this could be a good 0, 0 candidate. So first of all, let's draw a rectangle. Okay, it is a rectangle, but we shifted this incorrectly. The X shift is correct. Oh, maybe we can just do this. Should we shift it up? Yes. Yeah, perfect. So we have the rectangle. Now we need to come up with a way of representing this, a little triangle addition at the bottom of that rectangle. Let's see if we can do this without major hassle. So we have this vertex, this vertex, this vertex. Oh, sorry. No, we have, this is the starting one defined implicitly. We have this, this. So before we define the third one, let's go to here and our famous minus 0.1. And the last one. This is good, and 0.1 up. So now we should have created the outline of this shape. Perfect. So now let's see if that line here gets rendered. We'll probably have to get rid of the close line. But let's see if maybe. Let's see if it works with the clothesline first. So our last line should be icon width and a 0. Pretty straightforward. Let's see if that line gets rendered. It doesn't, but it is placed correctly. And the fact that we have here this empty bit here is because of the clothesline. Let's see if removing it resolves that issue. Yes, this is what I feared. Let's see what happens if we remove stroke loop. hold on. What if we just build two shapes and glue them together using the append operator? Back to the rectangle, and let's see if we can glue this with a choice shape. First of all, rectangle, perfect. I think we should be able to glue them together like that. And we are able to do this. And you see, we have this illusion, or maybe not an illusion, of the line running through the shape. But in fact, these are two shapes overlaid. Cool. So we have the rectangle. What we can do is to overlay that with a triangle. Now the question is, how do we translate this? So this is our triangle. We're closing the line, stroke loop. And we need to translate it only down. Oh, no, sorry. Down by not by half, but by the whole icon height. And let's see what happens. All right. Oh, we need to translate it down. Yeah, this is one of the advantages of using the append operator, where we used to have plus plus. It just gets you in that mindset of generally appending anything that is a monoid, and these shapes are monoids. Now, let's see if this works. No. So close. Maybe half. Perfect. So this is it. We have the choice ready. check the time. We're getting close to half an hour, so I probably won't have the time to tackle the second issue, which is to replicate this diagram. We'll get there. But in the meantime, let's PR this, and I'll show you what I promised at the beginning of the session, the new thing I didn't know about and that I learned about from the effective Haskell. Okay, so I can PR this a bit later, but not to waste time. Apologies. Not to waste time. Here is what I learned. And if you knew that, you can just ignore the rest of the video. But what I did learn is that if you're pattern matching on, say, a tuple, and you say my function, and as an argument you get x and y, and the body of your function is something, right? You can, obviously you have the, by defining your function like this, pattern matched, you get access to the first element of a tuple and second element of the tuple. But there's a trick where you can do, you can use this add operator, and by using that, you retain the tuple, the whole value, the first and the second element, as a tuple in that variable p. So you're binding the whole tuple to a p like that. And I would like to test it. So I think the best way to do this would be somewhere in the records. So here we have I'm not even sure if I have functions that I do accept tuples. That is not a tuple. Maybe in the layout engine. Here, something like that. Let's just experiment. Temp function, we're going to say it takes a tuple int string and it returns a string. Okay, pretty straightforward. So x, y, and it returns y. Okay, if we build this, it should build just fine. And the compilator complains that these are not used, but it's okay. Oh, what if we do what the book suggested? This should still work. So syntactically, it is accepted as just not used. So it seems to be working. Now, if I return a p, the compiler should tell me p is of the incorrect type. The function is expected to return a string, and you're returning a tuple. That's what I'm expecting to happen. Good and match type with string. Perfect. So Not that the book would be lying. I just wanted to test how it would work. So P really is of type tuple. So you can do second P, and it would have the same effect as if we didn't use the P at tuple at all. I think let's just read carefully in case I missed something. Perfect, yeah. So today I learned that you can use this P at, or just the at operator, and it retains the whole tuple here. I think that's pretty powerful. Let's see if this also works with records or data types. I'm not sure how I would use it though. Maybe like this. Yeah, let's stick to that P. Let's see what happens. It does work. Seemingly. Defined but not used P. This is great. So it means that it works for tuples. I need to do some Googling how it really is defined. Perfect. So if I wanted to return a P, the compiler should tell me you're trying to return an icon, and the function is expected to return a string. Sweet. This is really good. So I hope you find this useful. I certainly did. I can probably think of a couple of places where this would be very useful. Maybe we'll create an issue about that one day. I think HLint was just complaining about that 0.5 in the renderer. This is line 309. Yeah, brackets are not needed here. Let's just compile it. You know what? Let's just check. I'm not sure if it has a special name, but it is very useful. I see it's also used with the data type here, just with brackets. Beautiful stuff. Really nice. Okay, not to spend too much time on this. Right. I feel today's session was very productive. So plan for next time. I'm not sure yet. We'll think of something. Maybe it is a good time to start thinking about implementing a troubleshooting mode where fail points are not rendered, helper files are not generated, etc., etc. But let me think about that. And let me also think about representing drakon icons, aka letters, a little bit differently, but that's going to be most likely a bigger project, because it will impact also how we lay out those icons. Anyway, not a problem for today. Thank you very much for sticking with me. I hope you have a fantastic day and see you next time. Bye.